Welcome back everyone. In today's video, I will discuss about threading in Python. So the topics that we are going to discuss are what is threading, how to implement threading, when should we use threading. So what is threading? Before going into definition, let's take a real life scenario. Imagine that you are doing some houseworks like cooking meals, cleaning house and doing the laundry. Basically you have 3 tasks to do. So first you start by cooking breakfast, then move to cleaning the house and finally laundry. Each task is completed one after other, which can take significant amount of time. So this can be considered as the task without threading because you are doing tasks one by one. Let's consider this scenario with threading. If we assign each task to each of the member in the family, for example, cooking can be done by one member and cleaning can be done by other member and laundry can be done by other member. So each person work independently and tasks are completed concurrently. So this will reduce the overall time spent. If all of the members start work at the same time, all the tasks can be completed in lesser time. Similarly, in Python, we can use threading to improve performance, which will allow you to perform concurrent execution of tasks. Let's take 2 functions to demonstrate threading. Here we have 2 functions named first task and second task. Both functions doesn't have any logic but just a sleep method to add delay of 2 seconds. If you call these functions without threading, then the total time taken will be 4 seconds because they are executing sequentially, which is one by one. If we use threading in the same code, the total time taken will be 2 seconds. So here we reduced almost 2 seconds. So both functions executed concurrently so that the performance is improved. To implement threading, we need to import the library threading. For creating threads, we can use threading.thread. Here is an argument called target to pass the function which we need to add in the thread. As you can see, we created 2 threads for 2 functions. To start the thread, we can use thread.start. Thread.join is used to wait the main program to complete both the threads. So this is the basic implementation of threading. We can also use thread pool executor for this purpose. Thread pool executor is a part of the concurrent feature module in Python, which introduced in Python 3.2. Here is the same code with thread pool executor. For using thread pool executor, we need to import concurrent.futures. In this code, we use context manager to create a thread pool executor object with a maximum of 2 worker thread, which means 2 threads at a time. Inside the with block, we submit the first task and second task using the submit method. When you submit a task to the executor, it assigns the task to one of the available worker thread for execution. So thread pool executor can be used to enabling parallelism and concurrency in your application. Let's take another example. If there is hundreds of document files inside a directory and you need to process all of these files, so the first thing that we do is reading all of these files one by one and process it, right? So this will definitely take some time because we are reading the files one by one. In this case, to improve performance, we can implement threading. This is the code that reads 100 text files and processing the files. Here we use threading to improve performance. So we have 100 text files named as page1.txt, page2.txt, etc. There is a function called process page that read the file and processing the files. Here it's calculating the word count in each file. In the thread pool executor, we set 10 threads so that 10 process page functions will run parallelly. Means 10 txt file will processed parallelly. You can adjust the number of threads based on your system capabilities. In this code, we use future object to check if the task is completed or not. So it will wait for the task to complete and get the result. So in this code, we improved performance by implementing threads. Thread pool executor is nothing but program that manage and execute a pool of thread. So when should we use multi-threading? Here are some of the basic use cases that we can use multi-threading. First one is input, output, bound task. Example, downloading files. Multi-threading can be used to download multiple files simultaneously, which is especially useful when dealing with many small files or slow network connections. Second one is file input-output operations. Example, reading multiple files. So reading content from multiple files at the same time can speed up data processing task. So we can use multi-threading for input-output file operations. Next one is user interface responsiveness. Example, background task in a GUI application. Keeping a user interface responsive while performing a long-running task in the background, threading can be very useful. So you can run that background task using threading. Next one is database access. Performing multiple database queries concurrently to reduce wait times, threading can be very useful. So these are the basic use cases where we can apply threading. If the process is CPU bound task, then multi-threading is not a good option. CPU bound task means tasks that require intensive computation and utilize the CPU's processing power rather than waiting for input-output operations. Example of CPU bound tasks are mathematical computation, data processing, machine learning, etc. For these type of tasks, multi-threading is not a good option. In today's video, we had covered basic about threading and its implementation. In upcoming videos, I will cover more advanced topic about threading and more about Python concept. If the video is helpful for you, please support my channel so that I will upload more related videos. Thank you for watching and see you in the next video.